the project update for E4S. Well, E4S is an ecosystem for science. We have built a comprehensive, coherent software stack that we can use for HPC and AI workloads. It's a curated SPAC-based distribution of over 100 HPC packages. We have applications such as Warpex, NWChem, OpenFOAM, GROMACS. We have libraries such as Trilinos, Amrex, PETC, AI packages. You can see the full list here. We have support for installing E4S on bare metal using containers and even cloud images. And we have base container images which are compact that have just the vendor runtimes for the GPUs, and we have full-featured container images as well. We have support for SPAC binary build caches. We have architectures such as x86-64, PPC-64LE, AART64 with GPUs from all the three main GPU vendors, NVIDIA, AMD, and Intel, and also AWS AI specialized nodes. We have these packages that are optimized for GPUs and CPUs. We have other tools from E4S that can extend the SPAC installation in a container so you can expand the set of packages. We have support for launching MPI jobs efficiently so that you can use the bare metal network interface cards and use the most optimized vendor-provided MPI, even if you're using a containerized application, and you can swap MPI, distribute your application in a binary form, and we have tools that can customize the container images so you can start with a base image, add some new packages that you want, and create a custom container. We have joined HPSF because E4S exists to accelerate the development and deployment and use of the HPC AI packages. E4S represents the largest collection of performance-portable GPU-enabled libraries and tools supporting vendors such as NVIDIA, AMD, and Intel with support for their GPUs. And we also have support for AWS, Trainium, and Inferentia nodes, which are available only on the cloud provider. We support containers and turnkey from source build using SPAC of over 130 different packages. You can see that many of the packages that you will hear about here at HPSF conference are already there in E4S, including COCOS, including HPC Toolkit, libraries such as HPX, Amrex, Chapel. You will hear about Trilinos, data and visualization tools, including Viscourse, and AI products, including NVIDIA NeMo, JAX, Horoward, PyTorch, TensorFlow, most commonly used AI tools. And these containers are launched using Apptainer and Charlie Cloud. So you will see a large number of these packages that you will hear about already bundled together. So what E4S is doing is it lowers the barrier for entry. It makes these packages more accessible. You are able to use these packages in a binary form, and the entire portfolio is tested and validated on a variety of different platforms, from laptops to supercomputers to cloud platforms, providing confidence for users to upgrade with each E4S release. Our plans for the future include support for newer GPUs. We have a release cycle, one at supercomputing and one at the ISC conference, and you will see support for NVIDIA Blackwell in our next release and other CPUs in the future. We have plans for large language models and other AI packages that will feature prominently in the future. Integration between on-prem and cloud-based deployments, a common Python platform for deployment of AI tools, Julia and other languages that are relevant, specialized accelerator devices. We'll do more on AWS Trainium and Inferentia nodes, improving continuous integration and deployment using the Frank system at the University of Oregon. And I have another talk on Wednesday where I'll describe the CI efforts and what we are doing with E4S and SPAC. and also improving the MPI substitution integration with advances in SPAC. And we are looking at other SDKs. We have integrated the Neuron SDK for inferentia and Trainium nodes. We are looking at some quantum computing SDKs in the future. This is a list of new things that were introduced in the 24.11 release. And you can see a large number of AI packages there, including NVIDIA NeMo. And we have support for new architectures, MI300A from AMD, new languages such as Chapel, applications, Wharf, NWChem, CUDA upgrades, and Adaptive Computing's Heidi, a web-based platform for deploying this on the cloud systems. And this is the E4S.io web page where you can download the container images from here. And if you are looking at what packages are included besides the vendor runtimes from AMD, NVIDIA, and Intel, well, you can see many packages that are part of HPSF, including Amrex, including HPX. You can see Cocos. You can see other tools that are part of this distribution. Trilinos and HPC toolkit. And you can see the languages such as Chapel, Rust, Julia with support for MPI and CUDA, Python, and AI products, Zeiss from Sandia, and 3D visualization tools. It comes with Jupyter Notebook, Tau, Visit, Paraprof. Those who are interested in using Python tools, here's just a simple list of import statements that shows you what packages are already there in the container release. If you are deploying to the cloud, not only do you need to have an efficient intra-node communication substrate, you're also interested in supporting the network interface cards, which are distinct on these cloud providers, whether we are talking about AWS or Google or Oracle or Azure. And we have support for GPUs, and we have chosen MVAPIC Plus and built images which are now available and accessible using Heidi to launch jobs using multiple cloud providers. With Adaptive Computing's Heidi product, you can just launch the image of E4S, Paratools Pro for E4S, on multiple cloud providers using a web-based interface. And then you can pick an image which is there in the marketplace. So for AWS, for instance, it supports both Slurm and Torque schedulers, GPU-accelerated desktops using DCV or the VNC. There are compute nodes with GPUs, support for Trainium and inferentia using Neuron SDK from AWS, Elastic Fabric adapter, and this is part of a DOE SBIR. And you can see not just AWS, but Google Cloud Marketplace or Azure Marketplace or Oracle. So all of these main 4 cloud providers are supported with GPUs. Here is an example of the SPAC output for the image. So E4S, in short, is an ecosystem for science. Learn more about it. I would like to thank the US Department of Energy, Office of Science, the PESO project, the Exascale Computing project, and if permitted, I may have a quick demo. So here, you can see all of these packages in this using a container. And once you launch the Singularity container, you can just import any of these packages and use it. Here is a SPAC output. You can see 185 different packages installed. You will find many of these tools that you use, tools like HDF5, PETC, Trilinos, HPX, Chapel, all part of the distribution. Here is output from SPAC on a bare metal install. This is on a NVIDIA Blackwell GPU, and you can see which packages are supporting CUDA and so on. So here you can see this is a containerized distribution, but 3D tools like Visit, or this is Visual Studio Codium equivalent tool, and you can just launch images. You can use the GUIs all through a container interface. So with this, I'll take on some questions.
Questions for Samir? There.
So one thing is not clear to me if you keep a separate repository from SPAC, or you repackage the SPAC recipes, let's say.
So it is built upon SPAC. There is a GitHub site for E4S which shows you all the recipes. It shows you the SPAC.yaml files and how we build it. And in fact, you may be interested in my talk that I'll be giving in the SPAC user meeting on Wednesday, where I show step by step how a new package gets integrated in this workflow, how the E4S CI is run on the Frank system to support multiple architectures, GPUs, and runtimes. Okay.
Hi. Do you have any stats on the adoption rate of this outside of the lab, so in the cloud, so particularly non-lab users using this on the cloud?
So
any cloud.
So as far as the Docker pull requests are concerned, we can see which images have how many downloads and pulls, and we can see the adoption rates based on that, because we do not require a user to specify their name or organization while downloading it. We can only go by the statistics. There's one Docker image, for example, from E4S that has over 1 million downloads. There are other larger images which have over 2,000 downloads from just Docker Hub. And I can share with you contracts that vendors have provided to us, which regions, for example, when somebody takes a subscription for the image on AWS, we get an email notification, and I can share that with you offline to show you the extent of usage.
Sure, thank you.
Other questions? Okay, one back here. Okay.
Thanks. Haha, I got it. Okay, so I noticed in your list there that Umpire was on the list, which is great. So it's a 2024.07 version, which is the version before the latest, right? So we had a release earlier this year. So I'm just wondering, how do these packages get updated as they, new versions come out? And then maybe certain versions have certain requirements that some people like and that other people don't. Like, how does that all get handled? So
often we talk with some of the developers if they have a specific preference that we package. And we have done this with, say, HDF5, where they said, please package it in this way. Many times before we do a release, we take a SPAC particular version of SPAC, and then the latest package in that SPAC, the default installation of that package is used if we have not received notification to do otherwise. So for example, at supercomputing or at ISC, whatever is the released version of those packages, that is what we will use. And we often have cutoff dates advertised on the web page which say that we are going to freeze the version of E4S, maybe 2 weeks before the release. So many of our HPC tools get released at SC, at ISC, so you can find those releases.
Yeah. I wanted to ask, you mentioned E4S has a lot of testing, infrastructure, and things like that. What is the scope of the testing for the package that you have? Is it comprehensive in terms of the platforms that E4S runs on? And do you test each of the packages? And what are some of the wish list items that you wish you had to fill in any gaps that you have?
That's an excellent question and a good segue into my next talk, which we will give on Wednesday. So please attend that talk. I'll go into the testing in detail, showing you step by step the large collection of packages, the range of GPUs and architectures that we are testing this on. So thank you.
All right, thanks, Samir. Okay, so next up is Eduardo Zoni. Okay, yeah, thanks, Samir.